In 2002, a team of Spanish wildlife biologists completed the first comprehensive census of every surviving Iberian lynx on Earth. The number they came back with was 94, not 94,000, not 9,400, 94 individual animals, the entire global population of the most endangered cat species on the planet, clinging to existence in two isolated pockets of scrubland in southern Spain, one in Doñana National Park and the other in the Sierra Morena mountains. No other wild cat in the world had fewer living members. The Iberian lynx was closer to extinction than the Amur leopard, the snow leopard, or the South China tiger. It was closer to extinction than any cat species had been in modern recorded history. By 2024, trail cameras, GPS collars, and field teams across Spain and Portugal documented 2,401 Iberian lynx living wild across the Iberian Peninsula, 470 breeding females, 844 cubs born in the wild that year alone, and established populations reproducing in 17 distinct geographic areas across 4 Spanish regions and southern Portugal. The IUCN officially downlisted the species from endangered to vulnerable. The project coordinator for the EU-funded conservation program called it the greatest recovery of a cat species ever achieved through conservation, and the population is still growing. What happened between 94 animals and 2,401 is not a feel-good nature clip. It is a 20-year campaign involving 5 captive breeding centers, over 400 captive-born lynx released into the wild, more than 200 voluntary agreements with farmers and landowners covering over 370,000 acres, highway underpasses engineered specifically for a 25-pound cat, a continent-wide effort to resurrect the European rabbit from its own disease-driven collapse, and a genetic management program so precise that every single lynx on the Iberian Peninsula is individually identified and tracked. This is that story. This is the full story, from the medieval abundance that once spread this cat across the entire Iberian Peninsula, to the collapse that left fewer than 100 animals alive on Earth, to the breeding program that scientists were not sure would even work, to what the trail cameras are now recording in forests and scrublands where no lynx has set foot in half a century. Most videos about the Iberian lynx show you a beautiful spotted cat and call it a comeback. This one follows the data 20 years deep into the captive breeding failures and breakthroughs, the rabbit disease outbreaks that nearly derailed everything, the roadkill crisis that is still killing lynx faster than the population can absorb, the genetic bottleneck that nearly made recovery impossible, and the scientific evidence of what happens when you return a top predator to a Mediterranean ecosystem that has been running without it for generations. Every claim in this video is sourced from the IUCN Red List assessment, the official Iberian Lynx Working Group Census data, peer-reviewed research published in Biological Conservation and the Journal of Applied Ecology, and the EU Life LynxConnect project monitoring records. This is not speculation. This is what 2 decades of field data actually document. But before you can understand what the Iberian lynx is doing now, you need to understand what this animal is, why it nearly disappeared, and why saving it required solving problems that no cat conservation program had ever faced before. The Iberian lynx is not a version of another cat. It is its own species, Lynx pardinus, found nowhere else on Earth except the Iberian Peninsula. It is roughly half the size of its northern cousin, the Eurasian lynx. An adult male weighs around 27 pounds and a female around 20 pounds. It has a heavily spotted coat that ranges from yellowish to rusty gray, a short black-tipped tail that looks like it was dipped in ink, flared facial ruffs that frame the head like sideburns, and long black-tipped ear tufts that give it one of the most distinctive silhouettes of any wild cat on the planet. Americans will recognize the general build. It looks like a stockier, more muscular version of a bobcat, but with longer legs, a heavier coat pattern, and the kind of presence that makes everything else in the scrubland suddenly look like prey. But here is what makes the Iberian lynx both ecologically critical and extraordinarily vulnerable. It is a trophic specialist. That is a formal ecological term meaning it depends almost entirely on a single prey species for survival. For the Iberian lynx, that species is the European rabbit. A female lynx needs roughly 1 rabbit per day to maintain the body condition required for breeding. In areas where rabbit density drops below a critical threshold, lynx simply do not reproduce. They may survive, but they do not breed. And a species that does not breed is a species on a timer. This extreme dietary specialization is the reason the lynx collapsed so catastrophically, and it is the reason its recovery required solving a problem that no one had ever tried to solve at this scale: rebuilding the prey base of a wild predator across an entire country before you could even begin to bring the predator back. Later in this video, you will see exactly what happened when the prey came back first and the predator followed. The trail camera footage from areas where lynx have returned after decades of absence is unlike anything the conservation models predicted. But first, how Spain lost this cat in the first place. When you lose a top predator from a landscape, you do not just lose a beautiful animal. You lose the ecological pressure that keeps the system beneath it structured. Spain lost that pressure gradually across centuries and then all at once. The Iberian lynx was once found across the entire Iberian Peninsula, Spain and Portugal, occupying Mediterranean scrubland, cork oak woodland, and the distinctive dehesa landscape of scattered oaks over open grassland that defines much of rural southern and central Spain. It was not common in the way that deer or rabbits are common, but it was present, a solitary, territorial predator operating across a range that covered tens of thousands of square miles. The decline began with habitat loss. As Spanish agriculture intensified through the 19th and 20th centuries, Mediterranean scrubland was cleared for cropland, plantations, and development. The dense, low-growing littoral vegetation that lynx need for denning, hunting cover, and territorial boundary marking was systematically removed across vast areas. Roads fragmented what remained. Rural development pushed deeper into the interiors. But the killing blow was not habitat loss. It was the collapse of the rabbit. In the 1950s, myxomatosis, a viral disease deliberately introduced to control European rabbit populations in Australia and France, reached the Iberian Peninsula. Rabbit populations crashed. Then, in the late 1980s, a second disease hit: rabbit hemorrhagic disease, RHD. The combination was catastrophic. Across Spain and Portugal, rabbit numbers fell by 80 to 95% in affected areas. The European rabbit, itself now classified as endangered by the IUCN, went from being one of the most abundant mammals on the Iberian Peninsula to a species in deep crisis of its own. For the Iberian lynx, which needed rabbits the way a koala needs eucalyptus, the result was predictable and devastating. Without sufficient prey, females stopped reproducing. Territories contracted, populations fragmented into smaller and smaller groups. Genetic diversity collapsed as isolated populations began inbreeding. By 2002, the 94 surviving animals were split between 2 tiny pockets, Doñana and Sierra Morena, separated by hundreds of miles of unsuitable habitat with no possibility of natural exchange between them. At least one population had documented father-daughter pairings. The species was not just rare, it was genetically cornered. What Spain did next would take 2 decades, cost roughly 90 million euros through 2013 alone, require the creation of an entirely new captive breeding infrastructure, depend on the financial backing of the European Union through its life conservation program, and demand something that wildlife management had rarely achieved at this scale: the simultaneous recovery of a predator and its prey across a fragmented landscape while keeping farmers, hunters, landowners, and local communities on board. And it almost did not happen. The first challenge was whether the Iberian lynx could breed in captivity at all. No one had ever tried. Scientists knew almost nothing about lynx reproductive biology. The species is solitary, territorial, and notoriously aggressive during breeding season. The question was not academic, it was existential. If captive breeding failed, the only option left was to watch the species go extinct. In April 2002, a young female lynx was captured in Doñana. Her name was Saliega. She would become the most important cat in the history of Iberian conservation. Saliega was brought to the El Achabuche breeding center, purpose-built inside Doñana National Park specifically for this program. And on March 29, 2005, she gave birth to 3 healthy kittens, the first Iberian lynx ever born in captivity. What happened next took roughly 5 years, and it produced the scientific foundation for the largest cat reintroduction program in European history. The breeding program expanded rapidly. By 2008, the first captive-born female gave birth herself, proving that captive-bred animals could reproduce, a critical question that had been unanswered. More breeding centers opened: La Olivilla in Sierra Morena, Zarza de Granadilla in Extremadura, Zoo Botánico de Jerez in Andalusia, and the Centro Nacional de Reproducção do Lince Iberico near Silves in Portugal. Over the following years, nearly 500 lynx were born across these 5 facilities. The animals were carefully paired based on genetic analysis to maximize diversity and minimize inbreeding. Every mating was a calculated decision, not a random pairing. Each breeding center operated independently in terms of physical facilities, but was managed as a single genetic population by coordinators who tracked every bloodline. But breeding cats in captivity was only half the problem. The harder question was whether a captive-born lynx could survive in the wild. The answer came starting in 2009, when the first captive-bred animals were released into the Guadalmelato area near the Sierra Morena stronghold. The early results were cautiously positive. Survival rates during the first year exceeded expectations, roughly 70%, about 20 percentage points higher than the models had predicted. The released animals were finding prey, establishing territories, and in some cases mating with wild-born lynx from the remnant populations. The technique worked. Between 2010 and 2024, over 400 captive-bred Iberian lynx were released across Spain and Portugal, typically in groups of 5 to 11 per year per site, carefully chosen based on rabbit abundance, habitat quality, and the willingness of local communities to accept a wild predator in their landscape. Release sites expanded outward from the original Andalusian strongholds: Guaritzas, Matachel in Extremadura, Montes de Toledo, and Campo de Montiel in Castilla-La Mancha, and the Val do Guadiana in southern Portugal. Each released animal carried a GPS collar. Each was tracked daily during the first 2 weeks in a soft-release monitoring protocol. Each was individually identified and genetically catalogued. But the biggest surprise was not whether the captive-bred cats survived. It was what the released cats started doing in territories where no lynx had been seen in decades. By 2024, the Iberian lynx was no longer confined to 2 desperate pockets in Andalusia. It was reproducing in 17 distinct geographic areas across the peninsula. The total occupied range had expanded from roughly 175 square miles in 2005 to over 1,280 square miles. Lynx were establishing territories in regions where they had been absent for 50 years or more. Trail cameras, motion-triggered cameras, deployed by the thousands across release sites and surrounding habitat, were capturing images of lynx in places the program had never formally targeted. Animals released in one region were dispersing across regional boundaries, crossing from Andalusia into Extremadura, from Castilla-La Mancha into new territory in Murcia and Sierra Morena. And that is where the story gets truly interesting. Because what the trail cameras and GPS data are now documenting is not just a population growing. It is a population making decisions, choosing territories, selecting den sites, establishing home ranges that the models did not predict. And in doing so, it is beginning to function as something that conservation biologists call a metapopulation, a network of connected subpopulations that can exchange individuals through natural dispersal, rather than a collection of isolated fragments that need constant human management to survive. The first surprise was geographic. The conservation program released lynx in carefully selected sites based on rabbit density and habitat suitability. But the lynx themselves have been expanding beyond the formal release boundaries. Spontaneous dispersals between nuclei, individuals traveling on their own from one population to another without human translocation, have now been documented. This is the difference between a managed zoo population spread across enclosures and a wild population that is writing its own future. The lynx are choosing their expansion path, and they are choosing based on prey availability, cover density, and mate access, the same criteria their ancestors used for thousands of years before the collapse. And that was only the geographic surprise. What the lynx recovery revealed about the entire ecosystem was something else entirely. The Iberian lynx does not exist in isolation. It sits at the top of a Mediterranean food web that connects rabbits, raptors, foxes, reptiles, invertebrates, and the plant communities that sustain all of them. When the lynx disappeared, the entire structure shifted. Mesopredator populations, including foxes, feral cats, and genets, expanded into the niche the lynx had vacated. Rabbit populations, already devastated by disease, faced different predation pressure from generalist predators that hunted differently than the specialist lynx. The scrubland communities adjusted to the absence. Now the adjustments are beginning to reverse. In areas where lynx have re-established, the program's monitoring data shows a return of ecological structure that had been missing. Lynx presence has been associated with changes in mesopredator behavior as foxes and feral cats adjust their activity patterns and territory use in response to the return of a dominant predator. The rabbit populations that were painstakingly rebuilt as the foundation for lynx recovery are now being regulated by the predator they evolved alongside, rather than by the generalists that replaced it. The system is beginning to reorganize around the returned keystone. The full dimensions of that ecological reorganization are still being measured. The Iberian lynx recovery is one of the most intensively monitored wildlife programs in history. Every animal is individually identified, every breeding event is recorded, every dispersal is tracked. What this dataset reveals about how a top predator recolonizes a fragmented Mediterranean landscape and how the ecosystem responds will be studied for decades. But the direction is unmistakable. The third surprise was political. The Iberian lynx recovery was not achieved by a single country or a single agency. It was achieved through a multinational framework, Spain and Portugal working together, funded by the European Union's LIFE program, coordinated by government ministries, research institutions, non-governmental organizations, private companies, and local communities simultaneously. Over 200 voluntary agreements were signed with farmers, landowners, gamekeepers, and hunters, covering more than 370,000 acres of privately managed land. Wildlife underpasses were built under highways. GPS-based driver alert systems were integrated into navigation apps like Waze to warn motorists in lynx crossing zones. Road fencing was installed in high-mortality corridors. The program did not just save a cat, it built an entirely new model for how a continent can organize itself to bring a species back from the edge. For Americans, the parallel is direct. The United States faces similar challenges with its own endangered cats, the Florida panther, which bottlenecked at roughly 20 to 30 individuals in the 1990s before a genetic rescue effort using Texas pumas, and the ocelot, reduced to fewer than 80 in the United States, with habitat fragmented by roads and development in South Texas. The Iberian lynx program offers a proven model. Captive breeding combined with prey-based restoration, genetic management, landscape connectivity, and community engagement can bring a cat species back from single-digit viability to a self-sustaining wild population within 2 decades. No American cat program has achieved this scale of recovery. The Spanish model is now being studied by wildlife managers across the world precisely because it worked. The Spanish word for the Iberian lynx is Lince Iberico. Across Andalusia, the lynx has become a symbol of regional identity, appearing on municipal signs, tourism materials, and school curricula. In parts of southern Portugal, communities that accepted lynx reintroduction on their land now take pride in the animal's presence. The economic argument for predator conservation, often abstract before a program begins, became tangible the moment trail cameras captured images of kittens in territories that had been empty for a generation. But the deeper cultural shift is the one embedded in the landscape itself. The dehesa, the distinctive Iberian rangeland of scattered oaks, open grassland, and dense scrub patches, is one of the oldest managed landscapes in Europe, shaped by centuries of interaction between humans, livestock, and wildlife. The lynx evolved in this landscape. It was part of the system. When it disappeared, the dehesa continued to function, but without its top predator. Now, across thousands of square miles of Andalusia, Extremadura, Castilla-La Mancha, and the Guadiana Valley, the predator is back. The system is reconnecting. The project coordinator for the Life LynxConnect program, Francisco Javier Salcedo Ortiz, noted that there is still a long way to go. The target for favorable conservation status is 750 breeding females, and the 2024 census recorded 470. Roadkill remains the single largest cause of unnatural death. The European rabbit, whose recovery underpins everything, is still classified as endangered and remains vulnerable to new disease outbreaks that could collapse populations overnight. Climate change is altering Mediterranean habitat in ways that may force lynx into higher, cooler territory in the north. That is territory they have not occupied in centuries, and it may or may not support viable rabbit populations. But the trajectory is set. From 94 animals in 2002 to 2,401 in 2024. From 2 isolated fragments to 17 breeding areas across 2 countries. From a species that was closer to extinction than any cat on Earth, to a population that is now dispersing, breeding, and making its own choices across a landscape that is, for the first time in a generation, large enough to hold it. 94 lynx, 2 desperate pockets in Andalusia, a breeding program that scientists were not sure would work, 5 captive breeding centers, over 400 animals released into the wild, over 200 agreements with landowners and hunters, highway underpasses built for a cat that weighs 25 pounds, a prey species resurrected from its own collapse, and a population that is now 2,401 strong, writing its own future across the Iberian Peninsula without anyone opening a cage. But Spain is not the only place where a returned species is reshaping a landscape in ways scientists did not predict. In our next video, we go to Idaho, where in 1948, a state wildlife officer threw 76 live beavers out of an airplane with surplus World War II parachutes, dropped them into a valley that would become one of America's largest protected wilderness areas, and accidentally started an ecosystem restoration experiment that has been running uninterrupted for 77 years. If you thought saving the world's most endangered cat from 94 animals was impossible, wait until you see what 76 parachuting beavers did to 2.3 million acres of American wilderness when nobody was watching. You will not look at conservation the same way again.